All right, what about number two? So here's number two. The nature of the world is orderly, especially its deep structure that lies under and beyond the manifest world of ordinary perception. All right, so here's the next thing. Here's a presupposition that we would suggest needs to be in place in order to motivate the scientific enterprise. What is it? Well, the nature of the world is orderly. And so we can look at the world and understand that there is some order in the world. And so it's been arranged, it's been ordered in such a way, and that allows us to do science, right? He says science must also presuppose an orderly universe. It would seem that there are at least three ways in which the universe exhibits an orderliness that is relevant to science. First, the ordinary world of trees, animals, planets, and so forth that contain, objects that are large enough to see with the naked eye. So number one is the ordinary world that we see every day that we look out the window or get out of bed or whatever. Right?
And again, part one, the first issue, would also argue against that.
Yeah. Number two, there's the world's deep structure. All right. So this is the world, he tells us, of atoms and molecules and so forth that lies behind or maybe underneath the number one manifest ordinary world. And to which appeal is made to provide a cause of an explanation for the ordinary world. So we have the ordinary world, and then we have the world's deep structure that gives us an explanation of the ordinary world. And then finally, he says, is the startling fact that mathematics applies to either world in an orderly way. So both worlds, right? Mathematics applies to the ordinary world, and mathematics applies to the, deep structure world. And he says that is a startling fact. And so he wants us to unpack these in turn.
Right. And, even when we start teaching children those concepts of, this is a tree, but also then within the tree, it's made up of molecules. And then one of the things that I do is say, here's the experiments that we can do. But even if we don't do the experiments, because of how the universe is ordered, if we know the math that's behind this, we don't even have to do the experiment to know what the outcome will be. And that's the great thing about physics and calculus in there as well. To begin with, he talks about with the phenomenon of the ordinary world most often exhibits an order such that laws can be applied to them. Again, this is something from the far reaches back of science, is you see a thing and you go, I wonder why. Yeah. Or you have something in place that has an explanation, and then you find something that doesn't fit within that model. Again, the star wanderers, the planets in the atmosphere. We know that there are things up there, but then there are these weird things that follow a different path than what the stars do. And so there we're able to find, just from our naked eyes, things that conflict with a pre-established set of ideas or beliefs. And so, well, then what do we do with that?
You're in the epicycles.
Right, exactly. Yeah. The spheres go away, and we just elongate them a little bit more. Such laws are indeed statements of the phenomenon's uniformity. Things like the planets will consistently behave in such way. Regarding the deep structure, an example of this scientific order is that atoms and molecules combine according to strict laws of chemical change. Your H2Os in there, or your NaCl's. The greatest thing to food is salt. Finally, there is the assumption that we can fiddle. With mathematics on a sheet of paper in our study without any regard to the world, and come up with mathematical formulas and equations that apply to and govern various phenomenon in the manifest and deep structure worlds. Again, that's the claim that you make to the children that you'll show them later on as they get more ideas of what the world looks like or should look like. And that's the amazing thing with math there. And amazingly enough, this actually seems to work. So why should we expect that? Why do we come up against those ideas, and why should we expect it? And we'll talk a little bit more about expectations of science as well.
Yeah, good. And so notice what he's going to do now is say, we say, well, that's common sense, these things, that kind of stuff. Well, maybe, but maybe not, right? He says in the history of Western thought, these assumptions have not always been embraced. Indeed, it is widely acknowledged as a matter of fact that the Christian view of God, especially as depicted in the Protestant Reformation, provided an intellectual ground for the assumption that the world is orderly, right? Many folks have made that claim. But he says it is typical that these days to hold a form of linguistic relativity. namely the view that it is groups or cultures or those who share a common language that carve up or construct the world and its order differently, right? So there it is there. What gives the world order? Well, it's our language or, our worldview or that kind of stuff, right? And so in this way, different cultures literally live in different worlds with different principles of order because they speak different languages and so forth. So the orderliness doesn't come from, the world itself. We somehow give it order by our language. He also gives the illustration here of Kant. Says, again, the order comes from within our minds, right? The mind gives order to the world. And so again, is the world orderly? Well, you have to argue for it. Some people say yes, some people say no, right? But that's a philosophical issue, not a scientific one.
Right. Well, the most important point for our purposes is that the existence of an orderly, deep structure has not been evident to many people, including many contemporary scholars. And he says, once again, his purpose here is not to resolve this conflict or take sides, although he might hold to a certain side, but that's not his purpose here. Rather, he's trying to show that a portion of the academic community rejects this assumption of science. And the content of this assumption of science, along with the arguments both for and against it, are scientific in nature, and we can test it, and we can break it apart in its atoms. No, that's not what it is. It's philosophical. It's not scientific in nature. And so again, if you're holding to the scientism that only the hard sciences can give you the truth, well, then this too, whatever part of the side is, there's a claim being made, but you're the scientist, this is in your field, which side do you fall on? Well, unless if I'm shown something that I can do the testing on, the hard sciences on, repeat it, write a paper on it, get peer reviewed, it doesn't make its way into the political nature whatsoever, then we're able to know truth that way. Except we're not able to do that here, and we're talking philosophical, and we have to make our argumentation, epistemology claims, and metaphysical assumptions. And that isn't in the realm of the hard sciences, that's in the realm of philosophy.
Yeah, good.